Have you wanted your developer team to utilize trigger handlers? Have you always wanted to implement trigger frameworks? Have you wondered about the drawbacks of trigger frameworks? In this video, Adam Olshansky is discussing trigger frameworks which will support you in your Salesforce learning journey. Welcome! It's Rachel and Jessica from 100 Days of Trailhead, the place where the tech community comes to learn Salesforce, learn tech, get inspired, have fun, and invest in ourselves. Whether you are brand new to learning Salesforce and starting from the beginning, or mid-career and skilling up for that new opportunity, we are your trail guides here to support you with an itinerary to help you get where you're going. You are in the right place. If you are new to our channel, make sure you hit the like and subscribe buttons. Don't forget to click on the notification bell so you can be notified when we release a new video. In the description below, you can find links on everything we mention in this video, in addition to links we find helpful like books that have helped us and our friends along our tech and Salesforce journeys. To find other helpful Salesforce and tech content, visit our blog at 100daysoftrailhead.com. In this video, Adam Olshansky is discussing trigger frameworks which will assist you in having code consistency while reducing redundancy and complexity. Adam is a 14-time certified developer at Google and Salesforce MVP. He is passionate about helping people to code on the Salesforce platform and enjoys giving back to the community. Your quest, should you choose to take it, is to journey with us through the adventure of learning trigger frameworks. Your quest begins now.
Okay, so like Adam is like one of our favorite people in the Ohana, and I'm mostly saying that because he's awesome, but then also he's from Arizona, so that like makes all the difference in the world. He is the best lip syncer in the world. I'm just putting that out there. He can lip sync and shake it off like nobody's business. Okay, so what I'm really actually supposed to really be reading his bio.
I think that was part of the bio though.
Oh. Okay, Adam Olshansky is a 14-time certified MVP working on, wait, I need 14 certification. No, 14-time certified Salesforce MVP working as a Salesforce developer at Google. He's worked with Salesforce for over 5 years, presenting at Dreamforce 5 times, and has also given Salesforce presentations in conferences as far and wide as India and Uruguay. He's passionate about giving back and helping teach people to code, specifically in the Salesforce ecosystem, and has been a volunteer instructor for 5 Rad Women cohorts focused on teaching women to code on Salesforce. He's also a 2-time defending lip syncing champion of Dreamforce. And he actually also is one, like I said, one of our favorite people. And I just have to say, he's just fantastic, and you guys are in for a treat. Adam Olshansky!
I have to also say I've been treated by his coaching, so right? All right. Go ahead, take it away, Adam.
Well, thank you both, and thank you all for being here today. Obviously, always happy to share my love for Arizona and the Ohana any opportunity I get. All right, so let me see if Zoom will let me share here. I tried opening Zoom earlier, and it decided to shut down Chrome instead, so see what happens. All right, I think I'm sharing now. Can you all see my screen? All right. All right, so I am going to be showing some code also. If it's too small or accidentally hidden for whatever reason, let me know. IntelliJ doesn't always like cooperating. But yeah, so today I'm going to talk about trigger frameworks. Let's realize I have a typo on the first slide already. That's okay. So as Jessica read my bio already, so if you aren't already following me on Twitter, feel free to at Adam17AMO. I also have a blog, adam2architect.com. And if your org is looking to move to the Lightning experience, I have a Pluralsight course at bit.ly/lightning migration. And then just a heads up, I really like bit.ly links, and we're going to be walking through some code today, and it might be hard to keep track of it all and or really dive down into each and every line. So we'll be providing links to all of the code that I show you in the demo today, if you want to read through it yourself afterward once again. All right. So cool. So I'm going to start off today just going over general triggers, kind of a refresh of triggers. And then from there, we're going to kind of dive one step further a few times. So we're going to go from triggers to trigger handlers. And then we're going to go from triggers to trigger frameworks. And then I'm going to walk through 3 different examples of trigger frameworks, demo each one of them, and then go through some comparisons, some drawbacks, and then wrap it all up at the end. So feel free to interrupt me with any questions. We should also have some questions at the end, and I'm also happy to be available afterward online to chat some more if anyone's interested as well. All right, so triggers. So just kind of a brief refresher of Apex triggers. So when we're talking about code in Salesforce, we generally, for the most part, have, at least in Apex, triggers or classes. And so triggers are kind of snippets of code that are fired as automated responses to database events. So database events being inserts, updates, deletes, undeletes, basically anything when you're saving some sort of data to Salesforce. These triggers can fire either before or after a record save when that part of the operation goes through. They're an example of Apex code, and you can have Apex triggers for just about any object in Salesforce. I think there are a couple of legacy ones that don't support it. For the most part, any object, standard or custom, can have triggers associated with it. So when we talk about before or after triggers, again, this is what we're referring to. So when you click that save button in Salesforce, or when you execute some code that performs some DML, it's going to go through all of these lovely steps here. And we're interested in the trigger portion. So either step 5 or step 8, right before that record is committed, or immediately after, or sorry, right before it's saved but not yet committed, or right after it's saved and gets an ID, but still before it is committed. And then just kind of going to highlight something that I'm going to kind of assume we're following. This concept of one trigger per object. You may have heard this best practice before. You may have also heard it with one process builder per object. Basically, the idea that we want to, one, control the order that our trigger fires all of our operations in. So if we have 3 triggers, there's not really any way to control which one's going to fire first. So we want to control the order the trigger fires in. And when something inevitably goes wrong, we want a single place to be able to debug everything. We don't want to have to go look in 5 different places in 5 different triggers.
Adam, he asked what happens if you have a managed package triggers.
So managed package triggers, there's not really any good way around that. So managed package triggers are going to kind of fire on their own. So there's not any way to completely get around that, but you can't really control managed package code anyway. So in terms of debugging, you're not really going to be able to debug a managed package trigger for the most part. You're going to have to reach out to the vendor for that. And same thing with this next point, you're not really going to be able to toggle the trigger behavior. If you want to turn it on or off, there's not really a way to do that with the managed code. For the most part, managed package code is only supposed to be running on the managed package objects. So if you have any functionality you've built, generally you're going to have to write some code to fire that logic. So yeah, not a perfect solution, unfortunately. But in terms of your code, one trigger per object is the most optimal. So if there are managed package triggers, you'll still reduce the number overall. All right, so I'm going to walk through a very basic trigger example here. So I'm going to bring up IntelliJ. And let's go into presentation mode here. Okay, so, all right, so I have a lead trigger, and the lead trigger is essentially going to fire before insert, and all it's doing is creating some variables, running through my trigger.new, putting all of the company values into a list called company names. We're then going to do a query on account to see if any of the names match. Basically, we're looking for duplicates. We're going to add any name that matches to a map, mapping our existing account name to the account ID. We're going to run through our leads again. And essentially, if we found any duplicates, so if there were any accounts that came up in that query, we just want to create a case and tie it to the existing account. So we'll still let all the updates go through, but we're just checking our inserted leads, check if there are duplicate accounts. For each duplicate account, we're going to create a case, and then we're going to insert the cases. So one thing, I did make it slightly more complex just to show, one, obviously triggers can get relatively complex, and also we're touching a bunch of different objects, so we're probably going to want a trigger for this functionality. But we're starting off again with leads, and we're ending up doing something with the cases object as well. And so that may come into play later. So we have a basic trigger just on before insert, and we're already up to almost 30 lines on here. All right, so let me go back to the presentation here. So that was our trigger example. And so that gets us to our kind of next topic, trigger handlers. So we had a single trigger that was 30 lines just for before insert. Inevitably, we're probably going to want other things to happen on leads. Maybe we want some after insert functionality. Maybe we want some logic to happen on update before or after. So we're going to want to expand that trigger. As we expand it, our trigger is going to continue to grow. The other thing our trigger doesn't really allow us to do is reuse code. So if we have code that runs before insert, and we have some similar code that runs before update, we're potentially going to have to play around to be able to reuse that code. There might be a better way to do that without having to put the code in there twice. We never want to have repeat code if we can avoid it. And the other kind of thing we might want to do is avoid having a bunch of complex logic and triggers. So as we add more functionality, our trigger is going to get really, really long. If we have to duplicate code, it's going to get even longer. And triggers kind of limit some of the things we can do in terms of jumping around in the code and making things easier to read and easier to test. So that's kind of where trigger handlers come in. And so a trigger handler is just going to be an Apex class that handles all of our trigger logic. So it's going to allow our code to be called from other code and also from tests, so we can test specific parts of our logic rather than the entire thing at once if we were to leave it in the trigger. And we're going to generally use specific trigger contexts and trigger variables to route to our various methods in our handler. Overall, trigger handlers will allow us to keep our triggers very simple, which will make debugging better. It'll allow for greater flexibility in terms of code reuse and testing. And yeah, as I said, code more reusable, unit tests much easier because we can test individual methods as opposed to having to test the entire trigger at once. And so let's go take a look at what a handler might look like, just extending this trigger a little bit. So we started off with a 30-line trigger. And I'm going to go back here. All right, so I am going to comment out this trigger. And instead of having this 30-line trigger that just handles before insert, I'm going to turn it into a 30-line trigger that handles everything. And so now we're going to add all of our events. We're going to have our before insert. We're going to have our after insert, before update, and so on. And as I mentioned, we're using these trigger context variables, asking the trigger, what type of event are you? And we're using these trigger variables to pass in trigger.new, trigger.old, trigger.newMap, and trigger.oldMap. And then if I go look at our handler class, we have methods in here. Basically, I copied and pasted the logic from our trigger and put it into our handler here. So we have our handle before insert method. We have our after insert method, our before update method, and so on. So all these methods are going to be blank because we don't need them right now. We're just replicating the functionality we had in our before insert trigger. So I just moved that here. Again, we're just checking our leads, getting our company names, checking the accounts to see if we have duplicates. And if so, we're creating cases. And we passed in our trigger.new variable here. So this allows us to call handle before insert directly to do a test. It allows us to potentially call another method to avoid duplicating code in case we want similar functionality for before update, for example. All right, so simplified our trigger quite a bit, but there's still kind of more we can do here. And so this is just for before insert. And so if we think about all of our triggers, we potentially eventually get to the point where we have a lot of the same code in every trigger, right? Theoretically, every trigger is going to have, all right, some object trigger on some object with all of the events. If the trigger is before insert, call the handler for that object, call the handle before insert method, and then implement all those methods again. And we could do that and it'll work, but it's a lot of duplicate code, repeat code. And again, that's something as developers we want to ideally avoid. And so that's kind of where trigger frameworks come into play. So if I go back in here, so let's get into trigger frameworks now. So as I mentioned, we're going to have a lot of duplicate code in every trigger. Ideally, we'd like to simplify things, potentially only use the code we need. So I get locked in the dark here. And we also want to make our process more repeatable. So instead of putting all the same code, copying and pasting it into every single trigger handler, how can we make this process a little bit more repeatable? Which is also something we'd like to do as developers. So that leads us to trigger framework. So at a high level, a trigger framework is just generic code that can be extended for any object and provide the triggers for it. It's going to ensure that all triggers are consistently handled and that only the required code is needed. So every trigger we know is going to behave the same way. It also is going to allow for very simple triggers and very simple trigger handlers. So we started off with a 30-line trigger just for before insert. We went down to a 30-line trigger for all of the events, and we're going to knock it down even further. The other thing we saw in our trigger is we're manually doing all the routing every single time. So the lead trigger has its own routing, the account trigger is going to have its own routing, the contact trigger is going to have its own routing, and we want the framework to handle all that for us so we can implement it once and never have to deal with it again. And so that's what the framework's going to allow us to do. This also makes sure all of our triggers are consistent. So there's not going to be a question, well, does the lead trigger behave this way and the account trigger behave that way? We make sure all of our triggers are going to behave the same way. And it's going to make debugging a lot easier down the road. Trigger frameworks generally also allow for trigger bypasses. So there are generally always cases where we just want to shut down a particular trigger or a framework for a trigger. Maybe we're doing an upload of 10,000 lead records. We already cleaned all the data, and we don't necessarily want our lead triggers taking an hour to run through it all. So we just maybe want to turn them off, and the framework would allow us to do that and would allow us to maybe toggle triggers on and off in an easier way. It also makes testing easier if you're running into limits on testing and you don't necessarily need various object triggers running. You can potentially use frameworks to toggle the triggers on and off that way as well. The other thing frameworks will allow us to do is give us different behavior for triggers that start a process versus triggers that run in the middle of a process. So if you think back to our lead trigger I showed you as an example, that trigger is focused on leads. We're very interested in what's happening with the leads and records we want to create as a result of duplicate leads. So that would be an example of the leads starting the process. But if you notice, we also inserted cases. And so that's kind of in the middle of a process. We started off with leads and we went to cases. Do we need additional case validations happening if we're building the case ourselves? Maybe not. Maybe we don't need our entire case trigger to run on those cases we're inserting. Maybe we just want to insert them instantly and be done with it. So because cases aren't the core object being inserted to kick off the process, we potentially will want that to behave differently. The other thing is if we maybe insert some leads, it does some processing, and then some more leads end up getting inserted as a result. Maybe we don't need those leads to undergo the same triggers and validations that our initial leads went through. Maybe we do, maybe we don't, but it's good to have options and flexibility. And that's what frameworks will give us as well. All right, so I'm going to walk through a couple different framework options today. The first one is going to be what I'm calling the virtual class option. So this framework is going to have a constructor that we're going to call. It's going to have an enum of trigger context. So think like before insert, before update, after insert, all of those are just going to be in an enum that we can reference. We're going to have a method called setTriggerContext, basically identifying what trigger context we're in. The framework's going to give us a bunch of virtual methods that we can override. And I'll show what that looks like in a minute. And then we're going to have a single run method that's going to fire when the trigger executes. That's basically going to handle our routing for us and figure out where we need to go next in the code. All right, so this is going to be our the journey our code is going to go on here. So we're going to start with our lead trigger. We're going to go back to our lead trigger handler like we did before when we're talking about the handler. This time our lead trigger handler is going to call the framework trigger handler class. And the trigger handler class is going to route us back to our lead trigger handler. All right, so let's take a look at what that code looks like here. So I'm going to comment some of this out again here. So remember we went from 30 lines in our trigger down to, for before insert, to 30 lines for the entire trigger. And now if we take out the system.debug, we're going to be able to get down to a single line in our trigger.
Can you
and this is actually going to fail, so let me update this really quick also. So I'm also going to be updating our handler class.
Can you
and the handler class is going to be smaller as well. So before we ended up with 60 lines in our handler, and we were only using before insert. And so we're going to knock it down to about 30 lines here. And again, those 30 lines are just going to have to implement before insert. So let me make this a little bit bigger. Yeah.
You can't see your screen. It's not big right now.
Yeah, sorry about that. I was just editing the code, and so I made it a little bit smaller temporarily. But let me maximize it again here now. Okay. All right. So here, so we have our new trigger now. That's just going to be a single line, and it's going to handle all of our trigger for us. And all this is doing is calling our new trigger handler, sorry, our new instance of lead trigger handler, and we're going to call a run method. So if I go into lead trigger handler, what we've done to that is we now have a constructor, as I mentioned, and this constructor is going to be taking our trigger.new and storing it in a variable called new leads. We can, of course, add the other trigger variables as we need them, but right now we only care about before insert. And then we also noticed that lead trigger handler is going to extend our trigger framework. So that's going to be the trigger handler class. And so when the lead trigger handler gets instantiated in our trigger, it's going to call this constructor. And because we're extending our trigger handler as well, we're also going to call this trigger handler constructor. And so this trigger handler constructor is going to do a couple things for us. It's going to start off by calling the setTriggerContext method. And all that's going to do is call this other setTriggerContext method that figures out, again, what type of context are we in. So for our use case, we're going to go back to before insert. And again, this is just going to be implemented once, and then all of our triggers are going to be able to use it. Whereas before, we had to implement this for each and every trigger. So we're going to set our context to before insert. And once we have our context as before insert, if you remember in our trigger, we also called the run method. So our run method is then going to fire and say, okay, your context is before insert. Let's call the before insert method. And because this framework is a virtual class, and we've implemented a bunch of virtual methods here, this basically allows us to do two things. Number one, we can override any of these methods to implement them, or we can ignore them and it'll fail gracefully, or it'll exit gracefully rather. So if I go back to my lead trigger handler, here we've inserted the before insert method. We're overriding the default behavior. So if I looked in trigger handler, I'd see a before insert method. Because we have our own before insert method, we're going to run this before insert method instead. If we were calling before update, as an example though, we don't override the before update method. So instead, we're just going to come down to this before update method down here, and it's just going to exit without doing anything. We don't have to bother implementing the methods that we don't care about. If we want to implement a method, we can just override it, and our code will run there. If we don't care about a certain event, we can just ignore it, and the framework will take care of it for us. And so if I go back now to our lead trigger handler, I can see, again, we just have the same code we've had before. We take our leads, which are now in a variable called new leads, check for our duplicate accounts, and create our cases. And so our lead trigger handler, we just care about the methods we're interested in. Our trigger's down to one line, and the framework took care of everything else for us. If I go look at this in Salesforce now, I'm going to put our code journey off to the side over here. And I'm going to go to Salesforce. And I'm going to open up our developer console here. So I'm going to insert a new lead here, Carol Danvers, Captain Marvel. And when I go execute that, I'm going to go open up the debug logs here. And we're going to see, let me make this a little bit bigger. We started off running our lead trigger. Our lead trigger took us to our trigger handler, which came via the lead trigger handler constructor. So our trigger handler constructor ran. It called our set trigger context, which remember put us into the before insert context. We then, in our trigger, called the run method. So the run method in our trigger handler fired. The run method directed us to the lead trigger handler before insert method, so that ran. The code ran then again for after insert. So again, our lead trigger ran, sent us to our constructor via the lead trigger handler constructor. Again, set us to our set trigger context method. We determined we were after insert. We then ran the run method, decided to direct us to after insert. We didn't implement the after insert method. The default after insert method is blank, and so the trigger framework exited, completing everything we wanted to complete. All right, so that's essentially our first framework. All we had to do was implement a single class for the entire framework. We can provide a single trigger and a single trigger handler with a constructor and whichever methods we choose to override. And the framework, the one class that we implement the one time, is going to take care of everything else for us. And ultimately, what did this give us? So as I mentioned, completely knocked down our trigger down to a single line. Allows us to only have to write the code that we care about writing, so we can ignore all the other methods we don't care about. All the routing is handled for us, and it's handled the same way every time. So we don't have to worry about a bunch of duplicate code and only write the code we actually need. All right, before I get into framework number 2, any questions on how that framework number 1 was working? Okay. So next, framework number 2 is the interface approach. So this is going to be an interface. The nature of interfaces means they have required methods that you have to implement. Again, we're going to have some sort of dispatcher with a run method. And this one is also going to have the context methods in our handler and another method called isDisabled that we're going to be able to take advantage of. And potentially turn off the framework for a specific object, either via the Salesforce UI or programmatically. And so our code journey is going to look like this for this one. So we're going to jump over to contacts. We're going to start with a contact trigger. It's going to call the trigger dispatcher directly. The trigger dispatcher is then going to direct us to our contact trigger handler. And our contact trigger handler is going to be implementing the iTriggerHandler interface. So let's take a look at this code. So I'm going to get rid of our lead triggers here. Open up our contact trigger. And contact trigger handler and our iTrigger handler interface. Okay. So let me go back into presentation mode. So again, we have a contact trigger here. The contact trigger, again, is going to have a single line in it, aside from the debug statement. And here we're going to call our dispatcher, and we're going to give it a new instance of our contact trigger handler. And then we're going to call the run method on it. So if I go into our trigger dispatcher, we called the run method on it here. So we gave it an instance of the iTrigger handler interface. So if I open up contact trigger handler, I'll see we do indeed implement the iTrigger handler interface. And if I look in the iTrigger handler interface, it's just an interface that gives us a bunch of different methods we have to implement. So same methods we've seen before insert, before update, after insert, after update. And then we have another one here called isDisabled. And we'll take a look what that looks like in a second. If I go back to our contact trigger handler, we see we have the isDisabled method, before insert, before update, and so on. So we've implemented all the methods here because they are coming from that interface. And we've given this class using the interface to our trigger dispatcher. So we're calling the run method using the contact trigger handler. So we're running the trigger dispatcher. And the first thing we're going to do is check to see, is the handler disabled? Basically, did we want to turn off the framework for contacts in this case? And so if I jump back to contact trigger handler, I'll see we have a method here called isDisabled that we're using. And basically, we're checking to see a custom setting. Did you disable this trigger? And so if I go look in Salesforce, I have a custom setting here called trigger settings. And basically, for each object, I can check a box here to turn off the framework for those triggers. So let's say I'm doing a data upload, go to my custom setting, disable the triggers, do my data upload, turn the triggers back on, and the trigger framework's going to be able to handle that for me. The other thing I can do is if I'm running tests and I want to turn off trigger framework, I can just set this static Boolean value in the trigger handler, and that's going to do it. I can also, if I'm running code somewhere, like we saw when our leads were creating cases and we wanted to maybe turn off the case triggers, we can do that in that process as well. So this framework allows us to have an isDisabled method for all of our triggers. We can toggle the behavior on and off. If I go back to our trigger dispatcher, so first we check to see if the handler is disabled, just exit, don't do anything else. If the handler is not disabled, we're going to go, again, checking all of our logic. And this is implemented just in this trigger dispatcher class, and it's going to work for the same for all the triggers. So again, here we're checking before insert, great, call the before insert method, pass in trigger.new. If it's an update, call before update, pass in trigger.new map, trigger.old map. If it's after insert, pass in trigger.new map. If it's after update, pass in trigger.new map, old map, and so on. And so that's all this dispatcher is doing. It's just checking to see, is the trigger disabled? If not, figure out what context you're in and fire the relevant method. And because our trigger handler is always going to be an instance of the iTrigger handler interface, we know that all these methods are always going to exist for those trigger handlers. So in our case, again, let's pretend we're inserting a contact. We're going to run our before insert method. So in our case, it'll be contact trigger handler. And so if I look at the before insert method, the method itself is not very interesting. We're just checking to see if the last name includes the word test. But that's going to run here. And then after, it's going to run our after insert method. So if I go take a look at an example of that code in here also. Let me put our journey off to the side here again. Let me open up our developer console. We're going to insert a new contact, Tony Stark. I'm going to execute that. And look at the debug logs. And again, we're going to see we're starting off in our contact trigger. We're going to run our trigger dispatcher run method. We're going to check to see, is the handler disabled? Our handler is not disabled right now, so we're going to keep going. We're going to run our before insert in our contact trigger handler. We're going to exit out of that. Again, enter our contact trigger for after insert. The run method in the trigger dispatcher, which is going to check see if our trigger is disabled. If it's not, we're going to run our after insert method. And then if I want to, I can very easily go into my custom setting. So Salesforce wants to let me log back in. Later. Go back into our custom setting. And all right, edit this. Going to disable that trigger now. And so now that we've disabled the trigger via the UI, I can go run that same operation. And if I look at the logs for this one, we came into our trigger, fired the run method. We saw we were disabled, so we didn't call the before insert method. We went back to our trigger, ran it again, went to after insert, but saw we're disabled, so we didn't end up calling the after insert method. And so that is essentially the second framework. In this one, we have two files. One is the trigger dispatcher with a run method. And that's all that was in the dispatcher. And then we had our iTrigger handler interface, which had just kind of empty shells of all the methods we want to implement. And all we need to do is provide a one-line trigger once again, and a single trigger handler class that implements our interface and includes all the methods for each of the events, along with the isDisabled method. Once again, this gets us a great, nice, clean one-line trigger for each trigger. We implement all the routing the first time in our trigger dispatcher and don't have to worry about it again. All of our handlers are going to be consistent and all have the same methods in them. And we also here have multiple ways to deactivate a trigger, either via the UI or programmatically, which is going to come in handy potentially in test classes. All right, and before we go to the last framework, any questions on framework number 2, the interface?
Adam, I have a question.
Sure.
Well, can we use custom settings for like deactivating, turning a trigger on or off in prod? I was reading something about like using a workbench.
So workbench, I don't know. Let's see. Turn triggers on and off in prod. I don't know if you can actually deactivate triggers directly in prod via triggers. I think you have to deactivate it in a sandbox and deploy it. So this, it's not technically turning the trigger off. The trigger still runs. But in this case, the trigger behavior isn't going to fire because our framework is going to stop it from firing. So the trigger is still technically running, as we saw in the debug logs. But our before insert and after insert methods never ran because our custom setting deactivated the framework for that object.
Okay, so you don't recommend deactivating a trigger in prod at all, right?
I mean, I don't think you can deactivate a trigger in prod directly.
Okay.
So, yeah, so the framework here allows you to deactivate the behavior of the trigger. The trigger itself is still going to fire unless you deploy an inactive version from a sandbox.
Okay, yeah, someone asked me that question, so that's why I was curious.
Yeah. So this essentially lets you cheat. So it doesn't technically deactivate the trigger, but it's just as good as deactivating the trigger.
Okay, thank you.
Cool. All right, so that was framework number 2. So we saw the virtual approach, we saw the interface approach. Now we're going to get a little crazy and combine them. And so the first two were somewhat relatively straightforward. I mean, the first one had one file we used, the second one had two files we used, and then one file each for each trigger and each handler per object. As you can see by the increased number of bullet points, this one's a little bit more built out. So this is going to be a full-blown object-oriented architecture. And this is going to include, once again, a dispatcher interface with our required methods. But instead of being required to implement all the methods, we're also going to have an abstract dispatcher base class that's going to implement the interface and allow you to choose which methods you want to override. So it's kind of going to be the best of both worlds. We have the interface that has all the methods we want, and we have an abstract class that's inheriting from the interface that we can then extend and then choose what we want to override. We're going to have a trigger factory that's going to handle our routing and figure out the proper handler classes to use. We're going to have a handler interface that's going to have two methods, a main entry and an in progress entry. And so again, that goes back to the idea of, is this what kicked off your process, or is another process running? And also kind of has a built-in recursion check. You inserted some leads. If later on in the same process more leads get inserted, potentially you're going to want to handle that differently and not fire the entire framework again. The second interface is also going to have an abstract base class that's going to allow us to implement the interface and then extend the methods we want to override. And the other thing about this one is it has event-specific handlers. So if you think about one handler per object, we took our 30 lines that were initially in our trigger and we moved it to 30 lines on our before insert method. We potentially might also have 30 lines in after insert, 30 lines in before update, 30 lines in after update. As our org continues to grow, we end up with a 500-line handler class that's kind of hard to maintain. And then you add in some potential additional methods, and the class can get pretty big. And so what this is going to do, if you do have a lot of code and a lot of customization, you're potentially going to want a single class just to handle before insert, a single class just to handle before update, a single class just to handle after update. And it's going to make it a lot easier to separate out and also test and potentially debug the problem, because you're not going to have a ton of code in a single file. And so as you can see, this code is also going to go on a little bit more of a journey. And so we'll spend some time walking through each and every piece here. But again, we're going to start with our account trigger. From our account trigger, we're going to call our trigger factory. And our trigger factory is going to determine, oh, you're firing on accounts. Let's call our account trigger dispatcher. The account trigger dispatcher is going to extend our trigger dispatcher base. Our trigger dispatcher base is implementing the iTrigger dispatcher interface. So again, that was the kind of combo approach where we have the interface with all the methods. We have an abstract class that's implementing the interface, and then we're extending the abstract class and picking and choosing which methods we want. Our trigger dispatcher base is then going to do our routing for us and say, okay, great, you're using account, and specifically you want to go to the before insert trigger handler. And once again, our individual event trigger handler is going to extend a class, in this case, trigger handler base. And our trigger handler base is going to implement an iTrigger handler interface. And again, that allows us to implement an interface to keep our methods consistent, but also override the methods we care about and ignore the ones that we don't. So two interfaces, two abstract classes to implement them that we can override, and a trigger factory. So 5 different classes that are part of the framework. And so we're going to walk through each of them one by one. As I was going through the presentation this morning, I definitely got lost a few times. So if it does not all click, do not worry. But this is one of those things, you implement it once, it's a little confusing, but once you get it, you theoretically don't need to deal with it ever again, and you can focus on your individual event methods and your one-line triggers once again. So let's go through this this code here. So I'm going to get rid of all of our contact classes here. And I'm going to open up all the code, and then we'll walk through each and every one here. I'm going to move this over here so I remember what needs to be open. So let's start with our account trigger. Account trigger is going to open our trigger factory. Trigger factory is going to call our account. Account trigger dispatcher, which is going to extend trigger dispatcher base, which is going to implement iTrigger dispatcher. This is then going to call account before insert trigger handler, which is going to extend trigger handler base and implement iTrigger handler. Okay. So let's go through all of that one by one. So we start here. Once again, very nice and clean and simple, one-line trigger. It's going to handle all of our events. We're calling our trigger factory. We're going to tell it to create our trigger dispatcher. And we're going to tell it that we are using the account object. So each trigger essentially is just going to tell the trigger dispatcher, tell the trigger factory what object it's using. So if I go into our trigger factory, we go into our create trigger dispatcher method. We passed in, remember, account. This is then going to get a trigger dispatcher. So if I go down to get trigger dispatcher, again, we passed an account. Basically, this is just figuring out what is the name of your trigger dispatcher. So if you're a custom object, we're going to pass in custom object __c. We're going to strip that off the end of the name, and we're going to call a file called custom object trigger dispatcher. In our case, because it's a standard object, we can ignore that part of the code and just call account trigger dispatcher. And then essentially all we're doing here is saying, great, we have account trigger dispatcher. Let's create a new instance of account trigger dispatcher. And because the way we have it set up, we're extending our abstract class and implementing our interface. So our account trigger dispatcher is essentially going to be an instance of our iTrigger dispatcher interface. And then we're going to return that back to our create trigger dispatcher method here. So assuming we found the class we care about, if we don't, we can throw an exception. So we have an instance of iTrigger dispatcher called account trigger dispatcher. We're going to call our execute method within our trigger factory. And we're going to pass in that account trigger dispatcher. And so execute here. So let's take one step back and open up account trigger dispatcher so we can see what is in there. And again, this is extending this base class, which is implementing this interface. So once again, the interface, similar to the interface we saw last time, it has all these trigger methods: before insert, before update, after insert, after update, etc. We also, in this one, implemented a few additional methods if we have any bulk actions we want to take. And we also have an option to, after our trigger runs, if we want to do any sort of post-processing, we have a finally block here. And so we have that interface that has, again, the required methods. So we created a virtual class called trigger dispatcher base to implement the interface. The trigger dispatcher base will have to have all of the methods from the interface, so we can take advantage of the interface functionality. But because they're all virtual, if you remember back to our first framework, we can pick and choose which ones we actually care about for each trigger. So if we only care about before insert, that's great. We can put our before insert method in our account trigger dispatcher. We can ignore before update, and the framework's going to handle that case for us. And so if I go look at our account trigger dispatcher again now, we can, again, pick and choose which methods we want to include. So we have before insert here. In this case, we have before update, after insert, and after update, and then we can ignore all the deletes. We're just going to focus on before insert for now, though. And you see IntelliJ is telling us we're overriding the method in trigger dispatcher base. The method is initially implemented in our iTrigger dispatcher interface. All right, so let's go back to our trigger factory now. So we created this instance of account trigger dispatcher. That's great. We figured out it was a count trigger dispatcher we need. So now we're back in our execute method. Our execute method is going to create a wrapper object called trigger parameters, which is just literally going to be all of our trigger parameters, trigger.old, trigger.new, along with the context, before, is after, is insert, is update, etc. And again, this execute method is going to handle the routing for us. So if we're before insert, we're going to call the before insert method. If it's before update, we're going to call the before update method, and so on. Same routing we've been doing the whole time. And that's the entire trigger factory. We have one method to figure out what class we need, and then an execute method that figures out which method in the class we need. So we're calling before insert now, and we're passing in all these trigger parameters. So our account trigger dispatcher class, before insert, we overrode. So that's getting called now. And we have some additional variables that essentially provide our recursion checks. So basically we're saying, okay, did you, as part of this transaction, fire this method off already? Is the before insert method already running? If it's not, that's great. Let's tell the framework it is now running. And we're going to call another execute method. If we're already running this and now we're in a recursive state, we're going to call the execute method again, but instead of passing in a new instance of account before insert trigger handler, we're going to pass in null. Okay, so great. Our trigger factory decided we needed to go to account trigger dispatcher. It told us we need to go to the before insert method, and because we're in the before insert method, we're going to create a new instance of the before insert trigger handler for account. We're going to pass in all of our parameters, and we're going to pass in the before insert event. And that's going to be the same for all of our methods. So in our before update method, all it's going to do is call the before update trigger handler, the parameters, and the before update context. All right, so where the heck is this execute method now? Because it is not in here. So if we go hunt around a little bit here and we go to our trigger dispatcher base, we'll see that in addition to providing virtual representations of all these other methods, we have an execute method we're going to call.
Adam, we have a question.
Yes.
Asked, when would the before insert run twice in the same transaction on accounts?
So let's say we insert an account. That account creates a case. The case triggers fire, and as part of the case triggers, it creates another account. So now we're in a scenario where we created one account, which created another account, which is then going to create another case, which is then going to create another account, which is then going to continue executing and basically put us in a recursive state. And so we potentially want to be able to handle that. We don't want the same code running multiple times in the same transaction, because then we're essentially just doing duplicate things. I think. Is there one more question after that? Okay.
No, it was just a comment from Blanca saying it was a great question, which it was.
Yeah. Oh, yeah, no, definitely a good question. So in general, trigger recursion is something you may encounter at some point. Basically, if you're firing off some sort of process, you don't want account triggers running 5 times, because theoretically, your trigger processes are very complex. Let's say you have 10 SQL queries running per execution. If it runs 5 times, now you're running the same queries 5 times each, and you're potentially going to run through your governor limits. So you'd essentially want to have a way to either block the recursion from running at all, or potentially handle it differently.
We can also use binding, right, instead of static variables to control recursion.
So you can use binding?
Binding, yeah.
What do you mean by binding?
Like you can bind variables instead of static variables to control recursion.
So usually when I think about binding, it's in like binding variables within like SQL queries, or in within Lightning components. I might.
So we
So
cannot use it in triggers then?
I mean, I'm not sure about that definition of binding. It's possible that there's another way to handle it also. That I'm not aware of. The most common one I've seen is static variables, though.
Okay.
Yeah, there are probably other ways to handle that also, though.
Thank you.
Sure. All right. So going back to our account trigger dispatcher, we called our before insert method. We determined we needed the before insert trigger handler, and now we're in our execute method of the trigger dispatcher base. Okay. So the execute method is going to essentially check to see, did you call this including a new instance of the before insert trigger handler, or did you pass in null? And that is either going to tell us to run the either run the main entry method or the in progress entry method. And again, what that's going to do is potentially allow us to have different behavior if our current operation is what kicked off the process, or if that process fired a process that then ran the same code again. So when we insert a lead, maybe we want to also insert a count. But if we are inserting that account, which then inserts another lead, we don't necessarily want to insert a second account. So we can handle that second insert lead separately than the first one within the same transaction. So in our case, the first time running this, so we're passing in our account before insert trigger handler. We're going to assign that to our before insert handler variable. And we're going to call the main entry method in that class. So in this case, we are calling account before insert trigger handler. And account before insert trigger handler is, again, kind of the same approach we took with the account trigger dispatcher. We're extending our trigger handler base, and we are going to implement our iTrigger handler. The iTrigger handler is going to have just 3 methods: a main entry for the first time we're entering this event, in progress entry if it's not the first time we're entering the event, so the second or third time we're firing the same trigger in the same transaction. And then we're going to have another method here if we want to implement it called update objects that can potentially perform some additional DML for us all at once. So we're making sure we're handling it all after we do maybe any callouts. And again, because we're using the trigger handler base that's implementing the iTrigger handler interface, we can make all the methods abstract, and we can ignore methods if we don't care about them. So if I go now back to our account before insert trigger handler, we're just going to ignore the in progress entry and just implement the main entry method for now. So again, if we do end up with the in progress entry needing to be called, the framework will gracefully exit without bothering us. Here we're going to call the main entry. Again, we're not doing anything interesting here. We're just checking to see if we included the word test in our name. But we're more interested, at least for now, in the system.debug to tell us when this is actually running. And so you'll see if I go open the account after insert trigger handler, it's going to be the same thing in there, main entry method, and we just have a single system.debug statement. All right, so I'm going to go run the dev console for this now, keeping our code journey for this one over here. And so now when I'm going to go run this code, inserting a new account. Execute that. This is going to run, go through our framework, and as we can see, quite a bit happened here. We started off in our account trigger. We went to our trigger factory and created our, and then created the account trigger dispatcher. We then ran the execute method in our factory, which told us we needed to go to our before insert method in our account trigger dispatcher. The account trigger dispatcher then executed the execute method of the trigger dispatcher base. That routed us to our account before insert trigger handler main entry method. It ran that code and then exited. And then the process started again. We started in our account trigger for after insert, went to create trigger dispatcher, which got our account trigger dispatcher class name, called the execute method in our factory. In this case, we called the, so I didn't put the debug statement in there for after insert, but we called our after insert method in our account trigger dispatcher, which called the trigger dispatcher base execute method. And then we called our account after insert trigger main entry method. It's a bit of a wild ride there. And what does this look like from a diagram standpoint? So obviously this is a lot more built out also. This one included 5 files we needed, 2 interfaces, one for each the dispatcher and the handler, and then base classes to implement each one that we could override. So the trigger dispatcher base implemented the dispatcher interface, the trigger handler base implemented the trigger handler interface. And then we also had our trigger factory that kind of determined which object we needed. We then had to provide our one-line trigger, as well as our trigger dispatcher, which could, again, pick and choose which methods we wanted to implement. And then for each method, each event type we wanted to implement, we just need a single class for that event. One other thing we can do that I didn't show here, but we talked about files potentially getting a little bloated. One of the advantages of handlers at the beginning we talked about was also the concept of reusing code. So we could also potentially create an optional helper class for each object that's going to include all the code we want to reuse in each of our individual event classes. All right, so after all that, what did this end up giving us? It still gave us one-line triggers. It still gave us all the routing for us. And just like before, we were able to establish all the methods, letting us pick and choose which ones we wanted, kind of combining that virtual approach with the interface approach. The other thing was individual event handler methods. So if our code gets really complex, we can kind of separate that out and keep each individual event its own class, potentially cut down on the size of any one individual handler. All right, so ultimately, what are kind of the differences between all these approaches? So we saw all of them. Remember, we started with that 30-line before insert method, or before insert part of the trigger. And we got it down to one-line trigger for each one of these. So that's great. Never have to deal with the triggers themselves for debugging. All the frameworks handled our routing for us. All of them provided some sort of recursive capability. I don't think we demoed it in the first one, but the code that I'll give you the link to has a bypass capability that you can basically bypass the framework for that object also. The nature of being virtual methods for the first and third approaches let you kind of pick and choose which events you wanted to implement. Whereas the interfaces kind of tell you have to implement all of these methods. One of the drawbacks, if you call it a drawback to the kind of architecture framework, is the fact that you have to name all your classes a certain way. I usually think about naming as one of those things that at the time when I have to name something a certain way, I'm very upset. But later on, when somebody didn't name something a certain way, I'm also very upset. And so it's one of those things like it's annoying to do at the time, but you'll thank yourself later. But for this, you do have to make sure all of your handlers are named account, trigger, handler, contact, trigger, handler, account before insert, trigger, handler, things like that. The other thing with methods 1 and 2, at least in my opinion, there's minimal overhead. There's 1 or 2 files you need to implement one time and that's it. The architecture framework, you technically only have to implement it once, but it's a lot more involved and a lot more jumping around. So if you don't have a couple hundred lines in each of your event trigger handlers, that might be a little overkill. Might be a lot overkill also. And then as with anything, there are always cons to each approach as well. So the first framework we talked about, the virtual approach, we potentially could end up with very large trigger handlers as we start building our logic out. Interfaces, same thing. Number one, all the methods have to be implemented every time. There's not really any way to get around them. And also has the potential for large trigger handlers. The architecture framework, again, it enforces naming conventions, which can be annoying at times. A lot of code overhead. So if you fully build out this entire thing, you're going to end up with potentially 15 files per trigger, which may not be ideal, maybe necessary, but at least it doesn't sound very ideal if you can avoid it. And obviously, a little bit more involves a bit of a learning curve with exactly how that's working and how that's routing. And so if you're new to an org and you see this architecture framework implemented and you're saying, okay, why did the code send me to 15 different places to eventually get to my logic? That can be a little frustrating. But at the same time, like I said, if the code is very complex and built out, it could end up being a positive thing that everything's separated out and can be tested much easier. Ultimately, I think one of the things I wanted to hammer home with the third approach was there generally isn't a best strategy for all use cases. So mix and match where you can. If the custom setting to disable triggers helps you, great, use that. If an interface helps you keep everything consistent, great, use that. If you want the flexibility of the virtual capabilities, great, use that. Kind of pick the ones that make sense for your org. This is more about introducing you to the different approaches and capabilities of frameworks. As you can imagine, also generally easier to implement at the beginning when you're starting off with an org rather than later on. If your org's been around for 5 years, it might be hard to say, hey, let's go implement this 10-file trigger framework. But again, you know, incremental progress is always good too. And with things like the virtual or interface approaches, you could always maybe start off with that and kind of build up to a more robust solution. The other thing I wanted to emphasize from the drawback slide is that no one framework is perfect. There's good and bad to every solution, and there's no kind of one right answer to solving a problem. And so ultimately pick and choose what's best for you, take different aspects of each one, and whatever makes the most sense for you and your org, I would recommend that approach. So if you would like to find all the code I walked through, and I think these slides will be available after also, but the initial lead trigger can be found at bit.ly/lead trigger. When we move over to the handler, I updated the trigger code so that lead trigger can be found at bit.ly/lead trigger final, and the handler can be found at bit.ly/lead handler. When we updated the code again for that first trigger framework, the lead trigger can be found at bit.ly lead trigger simple. The lead trigger handler final version can be found at bit.ly lead trigger handler final. And the actual trigger handler class can be found at bit.ly/trigger handler. So that was for the first virtual framework. That's that code. Oh, if you want, I think maybe download it as a package at bit.ly virtual trigger framework. You can also find the interface one at interface trigger framework and the architecture one at arc trigger framework. And so I think some of those have different GitHub repos you can download and some more details that I didn't necessarily cover in the demos today. And so with that, thank you so much for listening. Feel free to connect with me on social media, and happy to take any additional questions.
You mean we're not going to get a sneak peek at your next karaoke song or lip singing song?
I have to choose that still. If you have any suggestions, let me know.
I just want to say, honestly, this was amazing. I'm sitting here thinking we have all of these developer woes at the university right now because we lost our developer and we're kind of in flux with a contract to hire person. So there's two of us that are trying to learn a little bit more, going through our 10-year org and a bunch of code that just is like, why did they do this? This doesn't make sense. Why is this like 3,000 something lines long? And this was amazing. Thank you very much for doing this.
Yeah, my pleasure. Yeah, glad it was helpful.
I had a question about how to try and keep your handler classes smaller. Do you tend to try to move methods that are sort of helper methods into a utility class elsewhere, or only if it's something that other class files might want to access?
I think it's kind of a case-by-case basis. My general approach is if it's a single small, like 3 or 4 line method, I don't really want a whole nother class, the overhead of another class for that. If I have 4 or 5 methods that I'm reusing, at that point, it's probably, I probably should put this in another class. So it kind of depends on how much code reuse there is. Generally, the smaller the class size, the better, and the more code you can reuse, the better. But there's not really a hard and fast rule necessarily.
And with that, we're at the end. Have you ever used trigger frameworks? What tips can you share with others? What other topics would you like us to cover on this channel? Comment below. We would love to hear your thoughts in the comments. If you've made it to this point, we want to take an opportunity to say thank you. Since you stayed with us, here's a bonus. Keep an eye on flows now that they have trigger functionality built in. For some of the less complex automation, that might be the right solution rather than embracing the frameworks. Thank you for spending time with us. Make sure you like this video. It helps a lot. Click subscribe and on the notification bell so you never miss another video. We also handpick these videos which we recommend you watch next. You can talk to us on Instagram, Twitter, and on our website at 100daysoftrailhead.com, all of which are listed below. Thank you for learning with us, and we'll see you back tomorrow.